Okay, class, no joke. I just recorded like a giant 10-minute video and I forgot to turn my microphone on, so I'm a little frustrated. I had a really awesome intro where I made some really cool joke, and it was one of those in the moment kind of jokes, so now I can't make it again, and boo-hoo. Anyway, today's lesson is over the difference of perfect squares. Well, what's a perfect square, you ask? A perfect square is a number that breaks into two identical numbers. We agree 25 is really just 5 times 5. And x squared, even though it's not really a number, we realize x squared breaks into x times x. And we all know the word difference in a math class is just a fancy way of saying subtract, doesn't it? Huh. Funny how that's a subtraction sign. So the difference of perfect squares factors out like this. We know it's going to be two binomials. And we know x times x is going to give me x squared, and I know 5 times 5 is going to give me negative 25, but, well, it's a negative 25. So that means one of these 5's has to be positive, and one of these 5's has to be negative. Let's check our math a little bit. What happens if I were to multiply these two things back together? I get x squared, I get negative 5x, oh, now I get positive 5x, and then lastly I'm going to get negative 25. Combining my like terms shows me that I'm going to get x squared, whoa, negative 5x plus 5x, those cancel, minus 25, which is what I was looking for. So the difference of perfect squares has this cool formula where you take the values that they break into, and one of them is positive and one of them is negative. Let's try another one a little bit faster. What if I give you x squared minus 49? Well, 49 is a perfect square. It breaks into 7 and 7. X squared is a perfect square. It breaks into x and x. And because it's the difference, we have different signs, one positive and one negative. If you don't believe me, go ahead, multiply it out. Tell me what you get. If you do believe me, come on now, let's circle it and box our answer. Let's look at another one. All right, x squared minus 81. We should be excited because what do we know about 81? It breaks into 9 times 9. X squared is a great one. It's x times x. It's the difference. So what we can do, this is x plus 9, and this is x minus 9. Good job, guys. I'm so glad that we're catching on to this. Now that I've made it nice and easy, let's make it more complex. What if I give you this? Mr. Tripp, that's the same problem that we just did. Or is it? Maybe it's slightly different. Well, let's talk about some similarities. I know that 81 still breaks into 9 times 9. But now I've given you x to the 4th. Ooh, x to the 4th, guys. That's kind of challenging. Do y'all think x to the 4th breaks into x squared times x squared? I'm starting to think that it might. In fact, actually, I totally think that it does. If you want to check it, remember, x squared times x squared, since we have the same base, we can then add my exponents, giving me x to the 4th. So it does work out. Let's use that to our advantage because what's happening? It's a perfect square, and they're subtracting. We know that means we're going to write my numbers, 9 and 9, and we're going to write my variables. It's not x anymore. It's x squared and x squared. It's a difference of perfect squares, so we have different signs. But wait a minute. This is really intriguing. X squared plus 9 is cool, but x squared minus 9, I'm starting to think this is not finished. How about y'all? Well, we just talked about x squared minus a perfect squared. We break that down. So I'm thinking x squared minus 9, well, 9 is a perfect square. X squared is a perfect square. They are subtracting. Couldn't I break these into their components? One's positive, one's negative. I'm thinking I totally could. X squared plus 9, don't be confused. That is not the difference of perfect squares, so we cannot factor that anymore. Do y'all think this could factor out all the way down to here? Talk to your neighbor about that for just a moment. All right, your moment's up. Stop talking now. Everyone be quiet. It's you boys, front row, be quiet. Girls, stop laughing. All right, I have one last one for you to try on your own. Try this one on your own. Notice it's not x squared, it's x to the 4th minus 16. Blake, pause the video. All right, so Blake paused the video, hopefully, and you guys work this problem. Right, don't let me down. And I'm really hoping that you guys broke this into an x squared and an x squared, a 4 and a 4, and a positive and a negative. And man, am I hoping that you got here and you said, wait a minute, we could go a little further. This is really x plus 2. This is really x minus 2. And this one right here is really x squared plus 4 because we can't really do anything to simplify it. If you got this answer, give yourself a round of applause. Quietly at your desk. No, boys, quietly. Quietly at your desk. And get ready for the next video. All right, guys, we got one more video coming up. We're going to look at the difference of perfect cubes. Man, it's going to be a showstopper. So y'all sit tight. This is Mr. Troop signing off.